All right. Hello, everyone. We're welcome to Safety and Leadership Week 5. Today we're going to be discussing tool safety. There's a few things we want to talk about, and we're going to go through this PowerPoint, and then naturally, just like Mike or I, either one, we're going to talk about some of the things that we've seen over our careers, our time in industry, and possibly even outside of industry as well. So let's jump right into it. The objectives at the end of this lesson, you should be able to explain common causes of hand tool accidents, lifts, safety rules related to hammers, chisels, screwdrivers, wrenches, and other hand tools. Describe the proper and improper dress for operating rotating power tools. Explain the safety operation of angle grinders. Explain why grounding is important on electrical tools. And describe the hazards associated with pneumatic tools as well. And also hazards associated with the engine-driven gasoline equipment. Alright, so first thing, hand tools are rarely the cause of injury. It is almost always our improper, unthinking use of them that causes injury. And that's true. For the most part, I mean, they're not engineered to hurt you. It's usually how we don't think about what we're going to do to get ourselves hurt. And so, it talks a little bit about here how they're used in everyday fabrication, construction, welding, and so forth. And since hand tools are used so commonly, they're often the most frequent cause of injury in most shops. That's a pretty big one to kind of remember is kind of like housekeeping, slips, trips, and falls. If we don't keep a clean house, then it's easy to fall over something, right? The most important safety rule is to think before you act. Take a couple of seconds to assess what it is going to happen before you take action. When I worked for one company in particular in industry, we used to have toolbox meetings every day as well, kind of like we do at safety in the morning. And we'd kind of describe what was going on for the day. And our foreman at the time used to always say, what if? All right, give me a what if. So like what if you're driving out to location, the road is muddy, it's Monday morning, coming off of a graveyard shift. A lot of times it's the things that we don't think about that we just become second nature for us, which we call complacency, right? Well, hand tools are no different. All right. So the next one is common tools and their hazards. So now we start to break down the individual ones. Before we get into common tools and their hazards, let's also talk about just hand tools in generals. Most hand tools do not seem especially hazardous. The following things are basic hand tool accidents or causes of hand tool accidents. Number one is a defective tool. Number two is wrong tool for the job, and that's really easy to do when took you 30 minutes to get up somewhere, or you're up on a ladder, or it was a strenuous amount of work to get into all the leathers and the protective gear, and you're down in a hole somewhere. But remember, having that right tool for the job is important. And then the other one is a tool used incorrectly, a crescent wrench or a screwdriver, the two that come to mind for me. And also that ties into like a tool's in the wrong place or your incorrect body positioning. I can't tell you how many times I've seen people push a crescent wrench away from them instead of pull to them. Okay, so let's talk about hammers. Without a firm grip, hammers can slip out of your hand. Hammers bounce off objects, hit other things, even you. When striking hardened objects like chisels and punches, hammers can chip the hardened tool and cause pieces to fly off at great velocity. So we had a student almost lose an eye that way one time. And that's very true. And if you get into certain locations, like in MSHA locations, when we did a lot of road construction, you might have hardened steel on hardened steel. So for example, like ripper teeth or something like that, that's designed to go inside of dirt and really tear it up. One of these might be the things that you say you're going to use either a brass hammer, a bronze hammer, or now what they call a soft metal hammer, right? So they're designed with a little more ductility in mind. They're not going to chip off or fracture like a ice cube if you were to smash it with a hammer and it just flies in all sorts of different pieces, or like glass. They will mushroom and mold around those type of things. Okay. Clamps. Clamps of all types are used in fabrication work, but they all have common risks. The main one being that they can come loose unexpectedly, especially when you're making impacts with the work with other tools. This causes parts to fall or move for the clamp to fall, and all of these situations can cause injury. And the other thing about clamps that I really want to point out is making sure that your clamp's in a location, particularly as welders. If we're cutting a piece out of something, let's say with an oxyacetylene torch or a plasma torch, we need to make sure that we're clamped in a place that's going to secure that piece that we're cutting off. I remember watching a group of guys one time working on the drag line in the coal mine, and they air arced this 1-inch plate out right above them, and it was literally like watching the old cartoons of Wile E. Coyote cut the hole in the floor all the way around him, and then he falls through it, right? So again, what if when I cut this last piece, where's it going to fall? What's it going to do? Is my body under it? Is there hoses under it? Is there wires and so forth? Chisels and punches, here they talk about as noted above, they're hardened. And so when they get mushroomed like that, when the edges get kind of folded over and mushroomed, then that's when we want to take them to the grinder and clean them up. We can clean them up and kind of round them off, give them a slight radius or a chamfer to make them acceptable again. Typically, after you've got through, let's just say a 1/4 inch or so, you'll notice that they start mushrooming a lot easier or folding over a lot easier. And at that point, it's time to get rid of them. Okay. You notice that underneath chisels and punches, it does not say a flat screwdriver. Okay, it's really important. That's probably one of the biggest ones I've seen a lot of times. All right, common tools and their hazards. Angle grinders are a big one for us, and so they're extremely useful. I mean, just in the beginning part of this picture, you can see 7 or 8 different things. He's throwing sparks right here in the oxygen fuel cylinders and so forth, right? And propane tanks might be in there. The other thing you got to think about is like these grinding sparks right here. If you've ever put them up against a car windshield, they'll melt into glass, right? So a lot of people, a lot of times, want to get a good glass pair of safety lenses. Well, actually, you don't. You want polycarbonate because glass don't melt the glass. Speaking of that, if you notice, he's not even wearing safety glasses, doesn't have long sleeves on or anything to protect the sparks from getting up here and sitting in the crook of his elbow. There's no guard on this grinder. He's using it one-handed. This piece is not even close to secure. And then old solvent as well, another flammable fuel right next to an ignition source. So just in this picture is a big issue. Go ahead and watch through this. There's a lot of really good things. These pieces can break off and do all sorts of crazy stuff for us. Okay? All right, we're going to break into electrical tools real quick because these are some of the big issues we have because a lot of us aren't electricians as well. So electricity is common job site hazards, so special care needs to be taken when using it. Before use, inspect tools and cords for damage, tears or holes in the cord and have any exposed any wiring that can either arc, shock us, or possibly even start a fire, right? Damaged parts, grinding wheels, bits, cracked cases, plug damage, so forth. But make sure that the guarding is in place and functional. Most of your guarding needs to be within a 1/16 to an 1/8 of an inch from the wheel or whatever grinding surface is going to be. Grounding of electrical tools, electricity will always find the easiest path to reach ground. You do not want to beat it, okay? So sometimes when we get shocked, a lot of it is the ground's on the far end of something, it's not making a good connection, and we are becoming the ground path for there as well. Power tools today are made using double insulated, which means that they do not require an external ground wire to be operated safely. Internally grounded tools have 2 prongs on their cords. Okay. Power tools that are not double insulated require an external guard wire to be operated safely. This ground wire is connected to the 3rd prong on the plug, so this 3rd prong must be in place and plugged into the proper outlet to be used safely. Don't cut a 3-prong off and just put a 2-prong on there. Okay? It's not a safe way to go. Alright? Do not operate any electrical tool if you're in a wet environment or standing in water. I've been here. I've been hit by one leg of 480, which is 277, while kneeling in water. It was an accident. Did a risk analysis on it. There really wasn't a ton of ways to avoid it, but there were some things that I could have done if I'd have been a little bit more thorough and we'd had a few more checks in place. I'm lucky to be here because of this today. And electrical impact type tools are becoming common. Make sure you're using bit sockets rated for the impact tool. This goes for air impact tools as well. And always wear safety glasses when using impact tools. Number one, you should be wearing safety glasses when you're doing any of this stuff, but especially impact tools. So your impact tools are usually a lot harder, a lot heavier duty wall thickness, and they're not usually the shiny chrome ones. They're more of a dark black oxide type of a socket. All right, pneumatic air tools. Now they have many of the same problems as electrical tools, or same hazards, I should say. Air tools require compressed air to operate, and this compressed air can be a hazard, so it creates a little different issue. Instead of electricity, the main moving force is the air. They create power and rotation, so they can cut particulate in the air, which is a hazard to your eyes and lungs. It can be the same thing for an electrical power tool as well. The other part of that I really want to add in is the air that's leaving the tool, because the air has to go somewhere. It just doesn't go in there and disappear. Like it goes in an impeller and basically comes out the other one. Just think about a windmill. That air coming out can stir up more dust a lot of times than just an electric operated one, which creates its own issues with just inertia. Okay? Don't remove the guards, make sure they're in place. Air tools, even small ones, tend to be very loud, so a lot of times you'll wear hearing protection. They require additional oiling, not just SAE 30-weight, it needs an actual air oil. Okay? They can contaminate work and welding areas, and a lot of times WD-40 can be used, so it might become a flammable hazard. When air hoses rupture or come apart, they can create their own issues, like whipping around in the middle of the shop like a snake, so to say. It can hurt people. There usually needs to be a braided whip attached to them, or some sort of a secure location or a pin that if they do come undone, they will go be a limited amount. You'd hate to have a 100-foot air hose that broke off at 98 feet of it, so you've got a 98-foot big long air hose just whipping from every direction to the next. I mean, possibly thinking about it from a diameter standpoint, you'd have a 200-foot diameter area that's now a possible source of injury. Gasoline-powered welders and generators, commonly in job sites. Storing the fuel gasoline is a common cause of a fire explosion. We've seen earlier, we talked about the grinding dust or the grinding sparks going into it. Gasoline vapors are flammable, naturally. Be careful of where you can store fuel cans if they do not fully seal. This also goes not just for gas cans, but oil and greasy rags, right? I mean, working on heavy equipment, a lot of times you're doing stuff like that and you're throwing grinding sparks and air arc spatter and even just welding spatter from 6010 or 7018 and slag can start these things on fire. And if there's another an additional fuel source like paper towels, rags, and so forth, it can get out of hand very quick. Also think about where the fumes are coming from. As somebody that lost my father to carbon monoxide, and I've an ex-HVAC tech, the fumes within a shop are a huge problem. You start feeling lightheaded, make sure you got adequate ventilation. Okay? So that's kind of discussed the section here about carbon monoxide. We can wrap it up here. I'm going to let you read through this on your own, and so forth. Alright. Just, again, when you're looking at it, think about what if. What if I push that crescent wrench and I lose my balance? Where am I going to go? What if I end up swinging this hammer really hard and I miss it? Where's the inertia of that hammer going to take me? Is it going to fall? And so forth. Alright. Stay safe. Inspect your hand tools quite often, and we'll see you in the shop.